Welcome. Today, we're going to break down a geometry problem involving an isosceles triangle and the properties of its medians. The problem states that we have an isosceles triangle with a base of 4 square roots of 2, and the median to a lateral side is 5. We need to find the length of the lateral sides. Before we jump into calculations, let's think about a few things. What type of triangle are we dealing with? It's an isosceles triangle. This means 2 of its sides are equal in length, and the angles opposite those sides are also equal. The problem also mentions a median. What's important about medians? The key property for this problem is that when medians intersect, they divide each other in a 2-to-1 ratio starting from the vertex. So how can we use the given numbers? We have the base length of 4 square roots of 2 and the median to a lateral side, which is 5. We can use these values along with the properties of medians and the Pythagorean theorem to set up the relationships needed to solve for the lateral side. To solve this problem, we will start by drawing an altitude from the vertex angle to the base. Let's call the triangle ABC with base AC and the altitude BD. In an isosceles triangle, this altitude BD is also a median. This means it hits the base AC at its midpoint D and forms a right angle. Our goal is to find the length of a lateral side, like BC. We can find this if we know the lengths of the altitude, BD, and half the base, DC, because they form a right triangle, BDC. We can then use the Pythagorean theorem. To find the length of the altitude BD, we'll use the point where the medians intersect. Let's call this point O. The problem gives us the median from vertex A to the side BC, which we'll call AM. We know AM is 5. The point O divides this median, AM, in a 2-to-1 ratio. This allows us to find the length of the segment AO. Now, consider the triangle AOD. Since BD is an altitude, angle ADO is a right angle. This makes triangle ADO a right triangle. We could find the length of AD because D is the midpoint of the base AC. Since we can calculate AO and AD, we can use the Pythagorean theorem on triangle ADO to find the length of the segment OD. Once we have the length of OD, we can find the full length of the altitude BD. Because BD is also a median, the intersection point O divides it in a 2-to-1 ratio. This means BD is 3 times the length of OD. With the full length of BD and the length of DC, we can finally calculate the lateral side BC using the Pythagorean theorem in triangle BDC. So let's begin by finding the length of the segment AD. First, we will find the length of segment AD. We need this length as it's one of the sides in the right triangle ADO. To find AD, we will divide the length of the base AC by 2. This is because the altitude BD is also a median in our isosceles triangle, so D is the midpoint of AC. The base AC is 4 square roots of 2, so half of that, AD, is 2 square roots of 2. Next, we will find the length of segment AO. We are given that the median AM has a length of 5. The medians intersect at point O, which divides AM in a 2-to-1 ratio. This means the segment AO is 2/3 of the total length of the median AM. To calculate this, we multiply 2/3 by 5, which gives us 10/3 for the length of AO. Now we will find the length of segment OD. We'll do this so we can later determine the full length of the altitude BD. We will use the Pythagorean theorem in the right triangle AOD. The hypotenuse is AO, and the legs are AD and OD. So the square of OD is equal to the square of AO minus the square of AD. We calculated AO as 10/3 and AD as 2 square roots of 2. Squaring 10/3 gives 100 over 9. Squaring 2 square roots of 2 gives 8. Subtracting 8 from 100 over 9 gives 28 over 9. So OD is the square root of 28 over 9, which simplifies to the square root of 28 over 3. On this step, we will determine the full length of the altitude BD. We need this altitude to find the triangle's lateral side. Since BD is also a median, the intersection point O divides it such that BO is twice OD. This means BD is 3 times the length of OD. We just found OD to be the square root of 28 over 3. Multiplying this by 3 gives us the square root of 28 for the length of BD. Finally, we can find the length of the lateral side BC. This is the main goal of our problem. We will look at the right triangle BDC. We know the lengths of the two legs. The altitude BD is the square root of 28, and the base segment DC is equal to AD, which is 2 square roots of 2. Using the Pythagorean theorem, the square of the hypotenuse, BC, is the sum of the squares of the other two sides. The square of BD is 28, and the square of DC is 8. Adding them together, we get 36. The square root of 36 is 6. Therefore, the length of the lateral side, BC, is 6. The length of the lateral side of the triangle is 6. If you have found alternative ways to solve this problem, or if you noticed any errors in our reasoning, please feel free to leave a comment below. Your insights are always welcome. Don't forget to subscribe to the channel for more geometry lessons. Until next time.